welcome to NPTEL course on power system protection. We are continuing with distance link on module 5. This lecture is on communication assisted relaying scheme. So, we will see how with the use of communication system we can enhance the protection with distance relay schemes. We will have the advantages, we will explore and exploit the advantages of how we can speed up the decision process using the communication system and how the decision can be also made more secure. Now, let us see the issues you can say that with the traditional distance protection. So, we know you can say that in an interconnected system, a set of relays at the bus M n and another set of relays at bus N will be there to activate the circuit breaker as and when required. So, here we have shown zone 1 from this side and zone 1 and zone 2 from M side and also zone 1 and zone 2 from this side. So, blue lines are the line coverage from M side and the from N side also we are showing for the zone 1 and zone 2. Now, what we see here that from one side when the relay takes a decision, let us say it covers through zone 1 80% and the rest of the portion is taken care by the zone 2. Now, that means that for the whole section of the line we have we do not have instantaneous protection and that leads to if the fault persists for 15 cycles and so with the zone 2, that may not be acceptable for a high voltage line from system stability point of view and so. So, that leads to a scope that can you improve the protection in terms of speed and so that is what we can say that we will see. Now, furthermore, what happens that if the fault persists in the subsequent portion you can say that from this side, even the fault happens to be here, then this you can say that side relay will see in zone 1 and it may go for instantaneous tripping. From this side however, it will continue. Now, that leads to you can say that because of the delayed tripping and so and it goes to instability kind of situation that may consider lead to cascade tripping and eventually a large scale disturbance into the system also for a very high voltage system, that may be a situation. Now, the other things which we have seen that in the distance relay performance also that when the we have remote in feed in earlier classes we have seen and also when you can say that we have intermediate T connection also in that case also you can say that the zone 1 has limitation and the in feed amount limits the performance of the distance relay schemes. So, the question here is that is there any scope to improve the speed of operation of distance relay and the reliability of you can say that more reliability of the decision of the relay distance relay. So, how the communication system can be useful and that may enhance the you can say that the performance of the distance relay, we would like to see that in this slide. So, we have this relay at M bus and we have the relay at the distance relay set at N bus. Now, let us consider we are assuming a communication medium is available and what you see here let us consider a fault happens to be here in this line towards the bus N. So, this is in zone 2 from this side and from this side zone 1. Now, what will happen here? So, this will see zone 1 and this will see zone 2. So, this side you can say the decision will be delayed and whereas this side you can say the decision will be quick. That means that if this fault is you can say that in zone 1. So, this relay ensures that you can say that the fault is inside this line and if we can communicate we can say that to the other side the trip decision taken by R N relay and if this side you can say that can get that information through the communication medium, then we can have, you can say that a oscillated trip decision by this communication medium, through which the corresponding decision of the other relay can be sent to the remote end relay, and we can make the decision faster, not waiting for the delay, you can say that time delay like 15 cycles or so by the zone 2. So, this kind of, you can say that information which is being transferred to the other remote end, you can say that is of importance, and then you can say that we will see how this communication medium can be also of importance in terms of that. But note that you can say that we are exploring here how only the decision of trip or block, you can say that can be transferred to other end. So, therefore, the communication medium which is being required is not of, you can say that very large, you can say that bandwidth also. Typically, between for digital, you can say that channels, it can be 9.6 kbps kind of thing and or more, and for analog channels you can say that it can be in the range of 0.5 to 1.5 kilohertz analog channels. These communication channels can be the power line conductor itself, the power line carrier, or it can be a pilot wire through dedicated communication wire for that one. It can be microwave, it can be optical fiber or radio channel, you can say that from point to point you can say that perspective or so. So, these kinds of communication channels are being used for the high voltage line protections in power grid aspects, which supplements the decision process by the relay. Now, through this, the advantages of, you can say that such an arrangement is that it gives us faster or oscillated protection, which is essential requirement of, you can say that very high voltage system from stability point and possible damage point of view. And then you can say that it also leads to, you can say, we will see how it leads to secure decision process also during the external fault situation and so in that perspective. And we see that you can say that in such an arrangement, we do not require high bandwidth, you can say that communication, even the power line communication can be also used. There are important, you can say that 5, you can say that this communication assistance schemes which is being used for high voltage system with distance link schemes: DUTT, direct underreach transfer trip; PUTT, permissive underreach transfer scheme; and POTT, permissive overreaching transfer trip; and the directional comparison blocking and unblocking is DCB and DCVB. Now, if you see this terminology, which we will discuss in details immediately after this slide, is you see here direct underreaching. So, underreaching, you can say that we know by this one, this zone 1, and the overreaching here we mean zone 2 or so, that we have already I am say that aware of. Direct, you can say that means it is without any other checking. Permissive means with permission. So, it has to go for an AND operation kind of thing. Here it is OR operation kind of thing. So, those are the distinctions you can say in terms of that. The other distinction from this terminology you can see, it is a trip, you can say that, and this is a block. So, whether you are transferring the trip signal or you are transferring the block signal, that is also important in terms of that. Now, these you can say that all these options of the schemes, communication assistance schemes with distance relay, which we will be discussing, requires they may require, you can say that, communication medium, and based on the communication available communication medium, the corresponding schemes can be selected. Two important points we will discuss here. A blocking mode that what I have told here, a blocking mode is one in which the presence of a transmitted signal prevents tripping of a circuit breaker at one end. So, a blocking, you can say that signal will be received from the remote end and it will block the circuit breaker you can say that at one end. that is what you consider a blocking mode operation, and a tripping mode is one in which the signal initiates tripping a circuit breaker. So, a tripping signal is being transferred to initiate the considered trip of a circuit breaker. So, that is you consider clear distinction between blocking mode and tripping mode. The use of a blocking signal is preferred in case an internal fault attenuates or distorts the signal, so that a trip signal would not be received at the other end. Suppose we are using the power line communication and a internal fault happens to be there, then in that kind of situation we can say that the corresponding signals may be distorted, and in that case we can say that a trip signal, you can say that to transfer a trip signal, because it is internal fault, may be difficult or may be leading to inaccuracies. However, blocking signal means the fault is not there in the line. So, for a secure decision we are transferring the blocking signal. So, it means that the blocking signal may be preferred for in that kind of situations, if the corresponding line, the communication medium is power line or so. But however, with the separate communication medium like microwave, fiber optic or any pilot wire dedicated communication system is available, then you can say that use both the options in terms of that. So, however, if you are having a dedicated communication system, it has associated economics also. So, that leads to the choice of that which one will be there. The important factor is the availability of the communication medium. We will go with one by one. You can say that this the techniques available, you can say that techniques, you can say that what we have seen. First one is direct underreaching transfer trip. Direct means without any permission from this one. So, without any waiting for the permission, we will see what is that concept. Underreaching means the zone 1 perspective and is a transfer trip, agree. So, this that is what schemes. So, these you can say that are the M and N bus, and we have the transmission line, and we have, you can say that the corresponding relay block here and relay block at the other end, distance relay block, and then you can say that is the associated breaker which are considered connected to this one. We will see, you can say that that this, let us say we are this at this relay, you can say that we will have a zone 1, zone 2 and zone 3, and so other zones may be also there, and similarly here also. But for this you can say that direct underreach transfer trip schemes, we require only the zone 1, you can say that decision process. Now, see here you can say that we are using, you can say that the zone 1 here. So, for this you can say that this side, let us you can say that a fault happens to be this side, this end, then we see, you can say that will be, you can say that the zone 1 will not pick up from this side, but zone 1 will pick up from this side close by this fault. So, you are using, you can say that red, you can say that dots here means trip, and green dots you can say that is no trip throughout this discussion. So, that means that this will pick up, and what will see, you can say that you will see here that the this will, you can say that from this one we have a OR, you can say that option, and here also an OR options, both are having similar, you can say structure. So, once the zone 1 you can say that picks up this one, it will transfer, see here this will transfer, you can say that transmit the corresponding signal to the remote end, and the remote end receives, the RX is the receiver, TX is the transmitter. So, RX receives, and then you can say that also you can say that is being an input to the, you can say the OR circuit. Now, what happens here, if the local one you can say that has not picked up, but it receive, you can say that from the remote, and you can say that there is a, you can say that zone 1 fault as picked up by the RN relay, and this is our operation. So, it will, you can say that go for the trip of the circuit breaker M also. Once again, that zone 1 you can say that at M end does not pick up. So, the fault will continue from this side till zone 2 picks up and makes a decision like 15 cycles or so, but from this side this is close by fault. So, zone 1 will pick up. So, that is why red frequency flag here, and that you can say that it means that what will happen, that these you can say that information that it has picked up by the zone 1 will be transmitted to, you can say that to this one, and this you can say that relay at this end will receive that signal, and with an OR gate of local you can say that zone 1 and the remote end you can say that zone 1, that is what underreaching element will be considered, will make a decision that this relay will also trip. So, what will happen that from this side also you can say that without any wait for the zone 2 decision, it will go for the trip. So, we are exploiting the advantage of a faster protection, oscillated protection. So, that is why it sends transfer trip signal to the remote end, and that is what the wording direct underreaching transfer trip. And this I am saying that the uses an instantaneous forward looking underreach element. So, the decision of the underreaching element, that is zone 1, is being transferred to the other one, and locally also as usual you can say that you will go for the trip decision instantaneously. The remote relay trips the breaker immediately upon receiving the transfer trip signal from the remote end. So, if the remote end sends the transfer trip signal, the local you can say that this relay also does not wait for of its own, you can say that, and zone 1 also within the OR gate concept. Now, one thing here you can say that the point is that that the no sections in this you can say that line that should be left out by, you can say that either by this or this. What we mean by here is that there must be an overlapping of, you can say that, zone 1 from M bus side and also N bus side. Otherwise, if a fault happens to be in that zone, it will continue without you can say that notice of this one, that will be picked up by the zone 2 perspective. So, that is you can say that the difficulty of this. The advantages you can say that of this direct underreach transfer trip scheme is that the schemes operate very fast for the closing faults, and it also clears you can say from the other end also, but it has associated disadvantages. It will not operate for faults beyond the underreach zone. If it means that if the corresponding fault from M bus side, as you have seen earlier, will not you can say that go for a decision if the remote terminal is open, if the end you can say side breaker is open, and if fault is you can say that they are in that line. In that case, you can say that the M side will be observing it in zone 2, not in zone 1. So, you cannot exploit the advantages of the high speed protection or oscillator protection. If the communication channel is inoperative, if the communication channel is not available, if the breaker is open, you can say that, and so then or for any reason you can say that if the communication is not available, then you can say that also there will be no information from the other end. So, you cannot exploit, you can say. For this reason, the duty schemes are often you can say used only as supplement to the other pilot schemes, which we will be discussing that subsequently. The other thing is that the duty signal is converted to trip without any local supervision. So, without any local supervision, the relay takes a decision once it receives a trip signal. So, if the trip signal is corrupted by noise also, you can say that, then it becomes a detrimental decision. That is you can say that the disadvantage of this one. This case is often applied with dual channels. It means that what is being that two communication channels is being used, and at the end you can say the end operation will be there to make that you can say that yes, it is not a corrupted signal or incorrect signal. By this you can say that end operation we can make. So, thereby you can say that the decision process can be more secure. The other thing is that if the fault resistance becomes higher, then what happens is that the relay may find it in zone 2, and if it finds in zone 2, even though fault is in the zone 1, then the advantages you can say that cannot be exploited in that perspective. So, that is why it has a limited you can say that resistance coverage aspects. We will go to the second one, the permissive underreaching transfer trip, permissive. So, with permission only you can say that the remote end will operate, it is not like the direct underreaching transfer trip and underreaching transfer trip. So, the word underreaching means again the zone 1 is the information platform, which is just to be transferred, to the other end. So, we will see you can say that again same 2 bus system, and then we have the relay bus, the RM relay and RN relay, and we have this communication arrangement, the RX and TX receiver and transmitter you can say that, as you have seen at both ends it is available. Now, you can say that the circuitry arrangement is you can say that the decision process arrangement is changed. We will see what is the difference. The schemes is similar to the DUTT what we have discussed, except that the signal sent is a permissive signal and tripping at each terminal is supervised the zone 2 units. Yes, it sends signals from both ends if the zone 1 finds the fault in zone 1, but the remote end it takes that signal and checks you can say that through zone 2, yes it sees in the zone 2 or not, and then takes a decision. Let us say fault is here close to bus end. So, the corresponding zone 1 will pick up from this side. So, it will trip immediately of its local breaker. and then you can say that it will consider sends you can say that the signal to the other end. So, this receiver gets you can say that signal that there is a trip decision by zone 1 from this side. Now, it goes you can say that to this block you can say that this block you can say is an AND block, and it compares with zone 2. Now, what it sees that from this end is the corresponding relay able to see in zone 2 or not, agree. So, that you can say that it will see this in zone 2. So, that is why the zone 2 is also trip here. Now, this you can say that zone 2 sees, and from that remote end also it is you can say that a trip decision. So, this AND operation says that now this is 1. So, it goes to the 1, it is 1, and this or you can say that is already you have seen in DUTT. So, either if the zone 1 is zone 1 you can say that is the zone 1 has taken decision, or a decision from you can say that the taken by the zone 2 and the remote you can say that information. If that is you can say that is also trip, then either of these you can say trip means the breaker will be open. So, what we say that as usual zone 1 will trip instantaneously, that is one perspective. The other is that if the zone 2 picks up from this side and you can say that it gets information from the other end from that zone 1 has picked up, then the relay also takes a decision process for the you can say that at this end also, and that you can say that the faster protection can be achieved even though the fault is close to the remote bus. So, similarly, you can say that if fault happens to this end you can say that this end you can say that will also pick up faster decision. And what we say you can say that the zone 2 here can be also you can say that a directional overcurrent also can be used instead of you can say that the normal zone 2, but in addition to that this zone 2 which we are talking about here for this business can be also consider an extended you can say a greater margin than what we generally say consider set in step distance schemes. Because you can say that you see here this is permissive you can say that case. So, the zone 2 also see, and you can say from this side you can say zone 1 also see. So, that you can say AND operation makes it you can say the decision process more secure, and therefore, you can extend the zone 2 to a larger area also. The PUTT has advantages. The supervision using overreaching element makes it less susceptible to misoperations, even to the noisy signal channels also, agree, because of the AND operation. Does not stand you can say permissive signal for out of section faults, true. So, that is why that AND operation advantages. Does not require additional supervisory log to maintain security under current reversal condition for parallel lines. See this parallel line condition. So, first note that the transfer trip signal is from the zone 1, agree, that zone 1 only sends the information and the zone 2 makes the AND operation. So, if a fault happens to be for this parallel line at F, so the current path in the 1 and 2 block which does not have a fault, which should be retained you can say that for this case will have you can say that fault path like this. Now, consider that what happens that these 4 now trips, breaker is tripped. So, the corresponding because the interconnected system, so the fault you can say that will go continue from you can say that fault path current becomes this. So, suddenly there is a reversal of current, suddenly there is a current reversal in this kind in this system. So, what is happening you can say that here if you see this 1 and 2, in both the cases the current is being reversed. So, they will see you can say a reversal of thing. Now, what happens that in the first case because this is forward fault, this is forward fault, this fault you can say that by this you can say the relay at this condition will be observed not be observed in zone 1 and will not be either it may be observed in zone 2 or zone 3. So, I am say that this one relay for this fault will not transfer any signal to this one, and at 2 you can say that does not see you can say that any forward fault. So, it will not transfer to this side. So, there is no exchange you can say of any information from either end you can say that for this line. Now, at this condition if you see you can say that then because this will see in zone 2 or so, and this will not see you can say that any forward fault. So, there is no transfer of any information or transfer trip generation for the first line because the fault is in second line. So, absolutely this you can say that arrangement PUTT arrangement has not a problem you can say that for the current reversal for the parallel line. The disadvantage you can say that of this PUTT scheme is limited fault resistance coverage, because I already mentioned for the DUTT scheme that if the fault resistance becomes high, the zone 1 may not pick up from both the ends also, and then you can say the fault clearance may be delayed you can say that, which may be tripped by zone 2 or zone 3. A PUTD scheme is ineffective for faults beyond the zone 1 is when the remote breaker is open. As already mentioned, if the remote breaker is open and then you can say the fault is continuing from one side, because there is no communication from the other end, you can say that other end will not detect in zone 1. So, this the advantage of PUTD cannot be exploited in such a condition. The next one on permissive overreaching transport trip. Permissive and it is overreaching. Earlier we were telling about underreaching, agree? That is the difference. Now, what is you can say that how this scheme functions we will see first. So, we have you can say that same two bus systems and the corresponding RM relay and RN relay, and they have you can say that communication medium to exchange the corresponding the transport trip, agree. So, it is the signal transfer is transport trip. What it does here that it uses an overreaching zone 2 element to trip local breaker and sends a permission signal to the remote end. So, what we see you can say that here that it uses an overreaching zone 2 element to trip local breaker. So, this you can say that we will see if the remote zone 2 element detects a fault, the remote you can say that trips the breaker when it you can say receives the permission. So, we see you can say that now here that suppose the fault is here in at this position and you can say that a fault you can say that at this position. You see here you can say that the zone 1 you can say that will not pick up, but zone 2 may pick up for this one very likely. In this case you can say that zone 1 will pick up, and zone 1 as usual you can say will open this breaker, but here also you can say that the corresponding zone 2 will also pick up. So, what you can say that we see here that the corresponding zone 2 now sends the corresponding signal, not zone 1 now. Note the zone 2 you can say picks up and sends the information and it goes to consider to this side and it comes you can say this one. Now, see here in zone 1 is not picking up because the fault is in the remote end, but the zone 2 is observing that fault. So, this is an AND operation from the remote signal, it also send is coming from the zone 2. So, both the zone 2s of these you can say that both sides relays and this AND operation will make the corresponding breaker to be open. So, that is you can say that the scheme you can say that or permissive overreach transport scheme. In this case for internal fault, this corresponding zone 2 you can say that elements which is having the AND operation from the remote and also it receives signals from the zone 2, agree? And that is what the overreaching transport trip scheme, not the underreaching. Now, for an external fault if we see here, what happens you can say that for this permissive overreach transport trip schemes, for this external fault this side will see in zone 2, but this side will not see in zone 2. So, what will happen here? If you see you can say that this will not pick up and then we will say you can say that no signal will be received from this side. So, this AND operation means no signal from this side, but local signal is there. So, this relay you can say that will not go for the block, not go for the breaker opening. So, this means this is an external fault. So, no breaker opening will be there. So, that you can say that is the perspective of you can say that what we see from this one. So, the decision is more secured in terms of that for external fault perspective, and but for internal fault as you have seen in the earlier slide, this will go for a faster tripping. The PUTD has advantages in terms of security, inherently better supervised, at it uses you can say that local fault detection by overreaching zone, not by the underreaching zone, permissive signal received from remote end. So, it is with permission. So, that is why AND operation. So, that is why it is more better secure, provides better fault resistance because it is in zone 2 not in zone 1. So, that you can say that is the advantages and as compared to for DUTT or the PUTD schemes. In DUTT and PUTD schemes, the transport the signal is being coming from the zone 1 not from zone 2. The disadvantage you can say that the dependability aspect will not operate for internal faults when remote terminal is open. So, from the remote and you can say that you will not find in zone 2. So, no signal will be coming. So, because it is a permission with permissive one. So, therefore, the local you can say that whichever you can say that side the breaker is connected also will not be able to make a decision. So, that is why the faster or isolated protections advantage cannot be exploited. In case of communication challenge in operative also the other end you can say will not receive any signal. So, then also you can say that you cannot exploit the advantage. Because the scheme uses an overreaching element to set permission, it needs additional supervisory logic to maintain security under current reversal condition on parallel lines. So, earlier we have discussed the parallel lines. Now, you see the situation same one we can explain here that fault is here. So, the fault path of current will be like this for the sound you can say that circuit. Now, this breaker is open now, circuit 2 breaker, circuit 1 you can say that the corresponding current will be having a reversal. Note that what will happen in this first case, the one will you can say that it may see this fault in the zone 2 and one may send you can say that signal to 2 side that it is in zone 2, agree. But in this case this you can say that breaker the relay associated with the 2 will not have a local you can say that zone 2 signal. So, it will not go for the trip decision, neither this will trip nor this will trip. But in this case what will happen, you see here that in this case this will this may see in zone 2, but this will not see in zone 2, agree. So, in general you can say that they will not operate as you have seen in the purity schemes, but in the first case zone 1 has already sent you can say that a communicated you can say that a zone 2 you can say that zone 2 you can say that detection, and if that signal will be used you can say that here and now 2 finds in zone 2, then there will be conflict of interest and that may you can say that lead to maloperation. So, therefore, you can say that so additional supervision is required in this kind of situation. Now, we will go you can say that to the other you can say that scheme directional comparison blocking DCB. Now, we have here blocking signal not tripping signal. So, in earlier cases only tripping signals were being transferred, whether it is under reaching from the or it is being from the overreaching means zone 2 or so. Now, here you can say that we have directional comparison. So, we are transferring the directional information. Now, how that direction information is there that we like to see here, and then you can say that how the blocking signal you can say that is being transferred, that we like to see here, that is the difference. So, we have same you can say that bus M and N, and then we have this corresponding R M and R N relay, and we will see you can say that what is being done. So, we have you can say that as we see from the you can say that diagram that we have you can say that zone 2 and zone 3 here, no zone 1 you can say that signal, zone 1 is as such you can say that local breaker it will trip, but now how to speed up the process you can say that and make the decision secure, that we like to see. So, this this blocking signal what happens here that at this you can say that bus we have a reverse look we have a reverse looking zone 3 reverse, it sees you can say that this side of the you can say that from bus M, line to be protected is bus M to N. Here also like you can say reverse you can say that zone 3 is there, that is you can say that the 3 R N, this you can reverse looking 3 R, the R stands for here reverse looking to this side, agree. Now, any external fault happens to be there for this F let us say, then this zone 3 R will see that fault in its forward direction. So, this fault is not this fault of this one internal fault. So, what will happen that signal will be transmitted to consider to the other end, and it will block this you can say that relay, this you can say that this relay. Once again this you can say that zone 3 R for this fault will find that yes it is the beyond the line, and will communicate you can say that this you can say a block signal to the other end, and then you can say that this you can say that you see here you can say that the corresponding operation here ending operation. So, local you can say that one sees in zone 2, local one sees in zone 2, remote ones you can say that sees in reverse zone 3, and that makes you can say the decision process. So, that this can be blocked at that time. So, therefore, a better security is achieved because the fault is in external fault. Similarly, a fault happens to in this also, what will happen here? This will find you can say that in the by this zone 3 are in reverse, and then that will be communicating to this end, and then here that will find in zone 2, and the corresponding relay will be a corresponding breaker will be blocked at that time. So, that is what you can say that the blocking you can say that signal, how that can be exploited for a secure decision for the system, and that is what directional blocking. But what happens that if the remote zone 2 element detects a fault, let us say for this fault, if the remote element zone 2 detects a fault, the remote relay trips the breaker after a short coordination time only. The remote you can say that trips you can say short coordination time delay only. If it does not receive the block signal, suppose you can say that it is in zone 2 and zone 2 operates in 15 cycles or so. So, that should operate. Now, this will operate in that after the 15 cycles or so, subject to the condition that it has not, you can say that received any block signal from the remote end. Agree? Otherwise, if you have zone 2, you can say that a fault at this point will happen to their internal fault, then you can say that the zone 2 will trip even it delayed, or you can say that it can use other, you can say schemes for a better decision. But DCB you can say is that for any external fault, the corresponding relay should not trip, that is the, you can say that advantage we can exploit. But this you can say that this relay you can say trips with a coordination time delay if there is no signal received from the remote end. So, if you see the, you can say that the characteristic in the move you can say that this is about that reverse you can say that zone 3 you can say that area, and in a quadrilateral also this is about the reverse zone 3 R area that you can understand from this plot, the diagram. Now, you can say that we are talking about earlier that suppose an internal fault happens to be there here F 1, agree. For this fault you see here the zone 2 has picked up and so also this zone 2. For F 1 fault, zone 2 from this side and zone 2 from this side will pick up. Zone 3 R will not see, because this is the reverse. Here zone 3 R will not, you can say that see in the reverse side fault we are talking about F 1. So, that means that for F 1 this fault internal fault to the line, zone 3 R no detection, zone 2 at M site detects, that is what red we have put, N site zone 3 R does not detect and zone 2 detects, agree. So, what will happen that no blocking signal is transmitted to other end, no blocking signal is transmitted to other end. So, zone 2 as usual will go for the trip decision, agree. Zone 1 as such is always there, but independently zone 2 can take a independent decision if we are talking about only DCB. For fault at F 2 external fault, see the situation, M site this site zone 3 R will not pick up, will not detect, but zone 2 will may detect. So, zone 2 detected, zone 3 R not detected, no block signal is issued from this side. Come to this side N side, zone 3 R detected, this is detects the F 2. Now, you can say that zone 2 at this end does not detect. So, therefore, you can say that this will you can say that send a block signal to this side, agree. So, for this F 2 it provides a block signal. So, block signal means this will not allow to operate this breaker at that moment, and that is you can say that the correct decision, that will be the correct decision for this arrangement, which we have already discussed in the earlier slide also. The relays waits you can say CTD to get block signal. If block signal is not detected in that CTD time, then only it trips. So, it has to wait like some 40 millisecond, you can say that, to get the, you can say that till you can say that it does not get a block signal perspective. The advantages of the directional blocking, you can say that aspect, is that the dependability will continue to operate regardless of, you can say that, open terminal communication channel failure. This is the advantages of, you can say that, the DCB scheme, that even for open terminal at the other end and also the communication channel failure also, it can, you can say that, will be inoperational. The disadvantage, you can say that the overtripping concern and no supervision during communication channel failure, you can say that, see, there is no supervision during communication channel failure, that is from the security perspective, that is a compromise. The delay, you can say that we are talking about, for internal fault it has to wait for CTD to get any block signal and then take the decision. If the CTD does not come till, you can say that 50 millisecond or so, then only it will operate. For external fault, it cannot distinguish whether the fault is an adjacent line or in the line to the next. Two things. It means that for internal fault, it has to wait, because for internal fault you can say that the block signal will not come. So, that is why this 30, 40, 50 milliseconds delay will be there, CTD time delay will be there. For external fault, the block signal will come, but it does not distinguish, you can say, whether that is in the adjacent line, or you can say that the line next to it, you can say that if there is a next to it line, you can say that it is to the next line, then you can say that the corresponding zone 2 or zone 3 operation should not be there. The last one on directional comparison on blocking. So, earlier we were talking about blocking, now it is unblocking, agree. So, unblocking means you can say that it is a trip kind of thing. What is being done here? A guard signal travels continuously between the two ends. What we have learned in DCB, that only a block signal is being used, is being issued from the remote terminal by the, you can say that reverse third zone relay to have a secure decision when the fault happens to be beyond the line. What is being done here? A guard signal travels continuously between the two ends of the line. A continuous signal is being transmitted from both the sides, that from both the sides. For healthy channel condition, this scheme operates similar to POTT, permissive overreach transfer trip, permissive overreach transfer trip, that is zone 2, agree. It is similar to that. If the local zone 2 element detects a fault, that is what POTT kind of thing, the guard signal is shut off, and a trip signal is sent. Once again, if the local zone 2 element picks up, you can say that detects a fault. So, now that continuous signal of guard signal is now, you can say that the mode is changed to a trip signal. So, this remote, you can say that relay detects that from the information coming from the remote side, the remote, you can say that relay detects the change. What change? Now, from guard to the trip, and then you can say that in case the remote zone 2 also, you can say that finds it, like in POTT we do, then it makes a decisions towards trip 1. So, here what happens that it is the trip signal, you can say that like POTT, you can say is being transferred to that one, and thereby you can say that for internal fault we can explore the advantage of faster tripping, which was the demerit disadvantage in case of simply I can say that the DCB scheme. Agree? The advantage of, you can say, such scheme is essentially this same secured as the POTT scheme, same level of POTT scheme security, dependability similar to the, you can say, DCB scheme. So, but as I said, you can say that with the internal fault, you can say that there is no, you can say that coordination time delay, you can say, will not be there here. Uses logics that ensures tripping for internal faults with the channel out of service. The logic permits a trip if the relay detects a loss of guard signal, and if the zone 2 element detects a fault, even the relay does not receive trip signal, that what we have narrated. The disadvantage, you can say that is that they require additional and continuous guard signal. So, continuous guard signal is to be transmitted. This, you can say that continuous signal is not required in earlier all the, you can say that schemes what we have discussed. So, that is the disadvantage, you can say that, of this scheme. So, in overall we see, you can say that we saw different communication assisted schemes, how communication facility, you can say that, can speed up the decision process, that faster decision, and also you can say that also they can be a secure decision like in DCB, and so you can say that secure decision can be also obtained from that perspective. But note that you can say that the communication medium available decides whether it is a block signal will be transmitted or whether it will be a trip signal will be transmitted, and all the, you can say that schemes, they have their own advantages and disadvantages. In some of the schemes, you can combine also these schemes also, and numerous schemes are being used, you can say that in different grids, and depending upon the communication availability, depending on the practice, you can say that in different things, depending on the short line and long line. For long line, you can say that communication medium may be costly also, and so, and like that, agree. So, all these factors decide that which schemes will be can be used, and so, and then So, to explore the advantage of speed and you can say that and security aspect. We through this you can say that we complete the module on distance relay. One perspective which here you can say that we will address again on distance relay, that the sensors, current transformers and the capacity voltage transformer aspect, they are in transient you can say that influence on the distance relay performance. We will discuss you can say that in the subsequent lectures. Thank you.